Hello all, let's get started here. So Chandnika, over to you.
Sure. Hi, everyone. Welcome to the session on Introduction on Google Gemma. I'm Chandnika. I'm an NLP developer in a US-based telecommunication company. So I majorly work on enterprise level NLP applications, and I have worked on various applications involving chatbots. And I have also productionized state-of-the-art models starting from transformers and into recent Gen AI models like open source Llama and also Mixtral. Also, I have won few of the global hackathons in my organization. So in today's webinar, we will do a deep dive into Google Gemma. We'll be doing overview on the responsible AI implementations and also a quick review on the architecture of Gemma, which is being used in the Gemini model as well. So let's get started. Yeah. So the agenda for today's session would be a beginner-friendly introduction to what is Gemma and what it is all about. And we'll start with a performance comparison among the multiple models available. And we'll see about the variants that have been released with this Gemma models. And also overview on the architecture and the components in it. And we'll quickly touch upon the training part of Gemma. And we'll have a code walkthrough and implementation. Yeah. So Gemma was released by Google DeepMind. It's a lightweight model, meaning it's a small language model. So we have seen a lot of large language models and we have witnessed its power. So in that family, we now have a small language model, but it is still on par with the bigger large language models. So it's a lightweight model, but a state-of-the-art open model. So by open model, they mean all of the Gemini and the OpenAI models were to the enterprise or for a closed paid version, right? But this Gemma model is an open model available to all the researchers and developers. So this is a very big leap from the DeepMind organization. And also, even though it is a smaller language model, by comparing with the performance of the existing other state-of-the-art models, it has outperformed in most of the tasks, starting with question answering, math, coding, and general reasoning. It is outperforming the state-of-the-art accuracies already. So with this OpenAI model, I mean open model, they are expecting the researchers and developers to use it more responsibly. Also, from the Google end, they have implemented the responsible AI practices and made ensure that it has been developed in a safe and responsible way. And they have also released a responsible AI toolkit for the developers to take it forward in a more safer way. So we'll explore more about these in the upcoming slides. And also the important thing to note is Gemma uses the same technology that Gemini is using. So the architecture, all of those are same with the Gemini models. So let's see what is special about Gemma, right? We'll try to decode the words that we saw in the previous slide. So when I mean lightweight, the number of parameters used are also light, I mean smaller, and they belong to the small language models. So thus we have a faster inference time, right? So the inference time gets reduced, and we also have very low resource expectation. It's not a very resource intensive model. We can even run this Gemma on a CPU or even on mobile devices. We can run this Gemma model with a very decent results. So that is one of the main feature of Gemma. And also a big leap forward from DeepMind is they have made it as an open model, right? So which creates a lot of possibilities for customization. So we can fine tune these models for our own use cases. We can load our own data sets and fine tune it for our specific needs. So they also have released a lot of sample examples, including the latest, PEFT methods like LoRa, like how to fine tune these Gemma models for our own data sets. We can leverage those Kaggle notebooks to, develop for our own use case. So that is one major leap from the DeepMind. And also that it's more focused on responsible AI development, right? So they are starting from the data curation point and the training point, and also with the evaluation point. They have ensured that all the responsible AI methodologies have been implemented. So we will see more on this in upcoming slides. So they have ensured that they have safely aligned to all the responsible AI practices, and they have also released a lot of responsible AI practices for the developers. And during the evaluation, they have set a very high bar to evaluate these responsible AI areas. For example, for the safety, fairness, bias, for these kind of areas, they have evaluated extensively and benchmarked against the metrics. And also, there is a Google Red team. So they are a set of ethical hackers. So they have invested a lot of time to evaluate these Gemma models. So this Red team has done a lot of activities, and they have ensured that it is completely safe and it is good to go from this Red team. So this is also one major factor, as it has been openly, publicly available as an open model. Responsible AI practices also are included in this. So there is a detailed blog about this
Now, Chandrika,
from,
quick question
yeah.
here. So,
Mhm.
are you saying this particular line of models
Yeah.
has gone through more responsible AI testing compared to other LLM models which we have seen? So, is there a special emphasis on responsible AI here, or is no more or no less than all other LLMs we have seen so far?
Yeah, so in the blog, they are not comparing against other models. But for this, since it's an open model, they have emphasized a lot on this responsible AI practice. Starting from the training till evaluation, it is in each and every step.
Got it.
Yeah. So not only from the Google end, after they have released as open model, as a developer, what we have to do, all those steps also they have given us, which we will see in the upcoming slides. Yeah. So to know more about its features, right, there is a detailed blog about it stating all of those. Yeah. So we'll compare the performance of Gemma with Llama models. So even though Gemma is a smaller model, it already outperforms in most of the tasks. If you compare with the Llama 2's scoring, right, it's very much better, and they have higher scoring. So in terms of math, in terms of coding, in all the aspects, Gemma has a upper stance. So from Google, they have released this evaluation metrics tool.
No, is it outperforming even Llama
Mhm.
2?
Yeah.
Because Llama 2 is a full stack model, not a just a lightweight model, from what I understand.
Yes.
I see. Okay.
True. Even on most of the aspects, it is outperforming Mixtral.
Wow. Okay.
Yeah. So whichever model you want to compare, and if you have any
Uh,
specific,
this is Gemma
yeah,
2, Gemma 2B or like 7B? Which model we are comparing right now? Because
yeah,
there are multiple
here,
variants in
yeah, this is Gemma 7B.
7B.
Yeah.
So Vivek, answer to that question is like 2B is lightweight model, 7B is still not that lightweight comparatively.
Right, right, got it. And Chandrika, I
2B,
believe this one is downloadable, unlike the Google
Mhm.
Gemini, which is only available as an API, right?
Exactly, yes.
Okay.
and and Chandrika, this 2B model runs on mobile app, right? And that is runs
Mhm.
on normal thing, not the 7B model, right?
Yeah, 2B runs on CPU mobile and 7B on the GPUs.
Correct.
Yeah. So on any particular specific task, if you want to compare, we have this UI available from Google Dev. You can choose which benchmarking metric you want to evaluate against. And for example, on this problem solving ability, if we compare Gemma with other models, it is on par with Mistral. And comparing to Llama 2, it has a higher benchmarking score.
Amazing. Because Mistral 7B, the latest
Hmm.
one, they are claiming in 7B they outperform everybody else
Yeah.
except GPT maybe.
Hmm.
But now you are saying Gamma is claiming they outperform Mistral. Okay.
Yes. So likewise, they have multiple metrics like on terms of coding or general reasoning, question answering. You can explore this tool. So on summarizing all of these in the original Gemma paper, they have released this comparison. They have taken Llama 2 7B and 13B with Mistral 7B and Gemma 7B. So Gemma is in green. If we compare the results, Gemma is outperforming in math, science, and coding, and it is almost equivalent or little higher than Mistral in question answering and reasoning.
Okay, interesting.
So on this, we will try to understand the difference between Gemini and Gemma, right? So both are from Google, but there are few differences between both of these models. So the goal of Gemini model is they are more focused on the enterprise grade. They wanted to release as an API and for the task focused applications they have developed that. But Gemma is mainly focused on the assisting the developers and the researchers to use it as an open model so that it opens lot more other possibilities. And also they are mainly focused on the responsible AI development with these open models. So this is the main goal of Gemma and the similar models. And coming to multimodality, Gemini handles text, images, videos. It can generate images, but Gemma is trained only for text-to-text conversion. It handles only text. It generates only text. That is one major difference. And also in terms of multiple language support, Gemini supports multiple languages, but Gemma supports only English. It is trained on English languages, and the tech output generation is also only English for now. And comparing to the size, Gemini is a large language model. Gemma falls under short language model, smaller language model when we compare the Gemma 2B variants. So as I mentioned, since Gemini is focused for enterprise level applications, their main focus task would be on very complex qualitative tasks. They are more into the results and they are more into handling very higher level of tasks. But Gemma is focusing on the general task like text generation, summarization, code generation, like the usual tasks that the developer would require. And also in terms of interoperability, Gemma is available as an API. We cannot download the models or access in our own environment. We have to do a paid version and access their API to get the response. But in Gemma, it is compatible and operable in multiple platforms. We can run it in Google Colab, Kaggle, or Vertex AI. In multiple platforms, it is supported, or we can even run it locally without the connection. So these are the major difference between Gemini and Gemma. So Gemma is focused for the developers and the research community with these many features. Let's see upon the variants they have released with Gemma. So in Gemma, they have two type of categories. One on the pre-trained version and the next on the fine-tuned version. So pre-trained version is like they have trained for the usual English corpus and it has learned the nuances of the training data set and the plain basic model they have released with the pre-trained weight checkpoints. We have two variants in it, Gemma 2B and Gemma 7B. But in the fine-tuned, It is like for a specific task, they have fine-tuned, for example, involving question answering or classification, summarization, comprising multiple tasks. They have fine-tuned and released as instruct models. So for both 2B and 7B, we have Gemma instruct, and for the pre-train, we have Gemma 2B. So this has to come here. So here we would have Gemma 2B English, Gemma 7B English. And for the fine tune, we have Gemma Instruct 2B English and Gemma Instruct 7B English. So we will see a sample result from both of these models. So what do I mean by pre-trained version and a fine-tuned version? So pre-trained version, it has been trained to understand about the training data, to generate a text, right? For example, when I ask a question like, what's the most famous painting by Monet? This is the output that we get, right? So this is not the response that we're expecting, but this is the core capability of the model. It is more focused on generating, predicting the next sequence of tokens, right? But the same one, if we try from the instruct models, the same question, it would be more on a question answering response. So by reading this question, it is generating the response that the most famous painting by Monet is water lilies, and so on. So this is the difference. Based upon our use case, we have to choose which variant we want to use. If we want to fine tune for our specific use case, we want to make it more customizable, we can take this Gemma model and fine tune for our own use case, right? But straight away, if we want to, use it for some code generation or for question answering, we can take these instruct models, which have been already fine-tuned for some instruction-based prompts. So this is the basic difference between both of these models.
Chandrika, one question on this, like the first, as you like, I'm just repeating what you said, just to clear my understanding. The Gamma 2B is first one is for the summarization rather, right? Not for questioning answering, right?
Yeah, for the basic summarization we can use, but it is more focused on generation. Like if I give a text, the output it would see what to generate next, right? But in instruction tuned, it is looking for a question answering kind of thing. It is thinking for this question, what has to be my answer? But in the previous one, it is like what would be my next word generation. It's not tuned for any particular task.
Okay, okay. A second question on top of it, is it actually the chain of thought? Is it also implemented in this? Does it follow up the question also and it provides the answer that way?
So in the paper, they mention in the evaluation, they are using chain of thought prompting
Okay,
during the supervised fine tuning process, during the
okay,
evaluation.
okay.
On that particular thing, they haven't mentioned.
And knowledge base, there's a mention because the chat GPT and all, they have the huge knowledge base, right?
Yeah,
That is
yeah.
all, like that's how it performs. So what about knowledge base? Did they mention like what knowledge base this model has?
Yeah, they haven't explicitly said what is the data set, but they are giving some words on, like they are feeding some English-based data sets from, the textbooks, some books. So I'll cover upon those in the training part. I will cover those.
Sure, thanks.
Can you go back to previous slide?
Yeah,
One before. Yeah. So this one. So, okay. So for both 2B, 7B, there are two versions. The
yeah,
instruct version is probably better on specialized tasks, right? And I mean, 7B will score over 2B any day. And
hmm.
instruct version of the respective one will be better than the non-instruct version, correct?
Yeah.
But is instruct version for specific tasks only, or it can work generally?
It can work generally. So for multiple tasks like classification, question answering, all of those they have already trained. But on top of that, if we want to fine tune also, we can do that.
Also, 7B is fine tuned
Hmm.
and 2B is not fine tuned.
Yeah.
Fine tuned on what?
Yeah. I will show that in the training part. I
Okay,
have
got
a
it.
small
Okay,
screenshot.
got it.
Sure.
Okay, okay, thanks.
So with this base, right, like to, I think by this you have basic understanding on like what is pre-trained and what is fine-tuned. Pre-trained is that it has just understood about the grammar and nuances of the language, and its task is to keep on generating the next sequence of tokens. But in instruct tuned, based upon a specific task, it has been already trained, like for question answering. On top of that, we can customize. So let's do a deeper dive into the comparison between both. So starting from the base difference between both of these in terms of the size, basically. So this is a lightweight champion, right? It's just 2 billion parameters and it can even run in mobiles. That's the major advantage of 2B. But if our focus is on power and efficiency, Gemma 7B will be suitable. It is more, it has a higher advantage in terms of performance. And in terms of resource constraint, if our use case is focused on CPUs or mobile devices, 2B is suitable. Or if we can use the GPUs or the TPUs, we can use 7B. Even for the inference, we need GPUs. And in terms of
Are you
inference, yeah,
100% sure for 7B you need GPU? Because for Llama 2 and Mistral 7B we have, I think the inference works fine on
yeah.
on CPU. For Llama 2 and Anthropic and Mistral, the inference runs fine on CPU. So here the 7B would definitely need a GPU.
Hmm. It runs, even the Llama runs in CPU, but it takes very long time.
Got it. Okay.
Yeah, and also the RAM requirement would differ for both. I will touch upon that as
Hmm.
well. But we can do, but if we are expecting, production level, GPU supports for the faster inference for 7B. And in terms of inference speed, 2B is super fast, and compared to 7B, it's little fast. I mean, it's fast, but on comparing both of these, 2B is fast. And in terms of performance, the 2B models are realistic and they are context aware. They can give a decent results. But on comparing 2B, the Gemma 7B outperforms most of the LLMs like we saw. Even the Mistral, for most of the task, it has a upper advantage. So for the ideal task suitable for Gemma 2B would be for the text classification and question answering. For these level of complexities, 2B will be much suitable. When we come to much higher complex tasks like code generation and summarizing a super big paragraph, Gemma 7B would be more suitable. So depending upon our requirement, we'll have to choose between the variants. So yeah, we will do a touch upon the responsible AI factor of Gemma, which they are mostly focusing on. So since this is an open model and available to all the researchers and developers, they have taken a lot of steps from their end also, but they are emphasizing that as a developer, we have to be more responsible in utilizing these. So starting with the training, right? So if you see here, we'll come to this, illustration later. But starting with the training part, they have used multiple filtering techniques to filter out harmful contents. They have a lot of CSAM scoring metrics and a lot of other scoring techniques to filter out any abusive or harmful content from the training dataset. So they have set a very high evaluation bar for this, and they have carefully curated this dataset. So that's one of the thing they have done from their end. And also, when coming to the evaluation part, there are a lot of data sets available publicly, which evaluates our model's performance and the way it responds against these responsible AI practices. Is it against any particular community? Is it following the safety and fairness approaches? Is it falling under the proper content generation policy? So, a lot of evaluation and lot of data sets they have evaluated and released this model. So they are also emphasizing the developers to do it as well, right? So for that, what they are suggesting for our developers is on the Responsible AI Toolkit guide. So if I can go to it, right? Yeah. So this is the Generative AI Toolkit. So they are mostly emphasizing on three things. One, on the safety policies and the safety classifiers we'll have to use. And we'll have to also leverage the LIT tool that they have given. So this one, I will show a small demo on it. We'll do a deeper dive into it. It's basically like explainable AI feature of Gemma. And also, they are emphasizing to include guardrails, right? On the safety classifier and the safeguards, as a developer, they want us to implement all the time as a responsible AI practice. So, for example, after the input and before it throws the output, we have to ensure there are safeguards. So, how do we ensure? They have suggested multiple techniques. How can we ensure such an architecture? Right from the prompt engineering, training, if we want to customize, how do we implement these responsible AI policies? And also like filtering out these contents. So, lot many guidelines they have given. So we will explore on few important things from this. So definitely go through this blog for further more information and when you start developing with Gemma models. So few of the important components of these are the learning interpretability tool. So this is basically explainable AI tool. So for each of the output, if we want to investigate from which part of the input has it actually thrown this output. So that's one important tool which we will see a detailed demo in the end. And they're also mentioning about safety classifiers. So they have opened two APIs. One they call as Perspective API. So this API will filter out contents that are harmful or not aligning with the responsible AI practices, right? If the output of our model is a harmful or abusive one, this Perspective AI will filter it out. It will provide a scoring through which we can filter it out. And it's a free API. We can use it. And they also have this text moderation service from Gemini. This is free to certain limit after which we'll have to pay for it. This also does the same thing. It moderates the output it is generating. So these two APIs for the safety classifiers, they are emphasizing the developers to implement. And also during the training phase, evaluation phase, they are emphasizing more to follow all the responsible practices that they have mentioned. So this is one of the important factor of Gemma models. So we'll do a quick overview on the Gemma architecture. So Gemma architecture follows the same architecture of Gemini. So they both are having the same architecture, but in terms of parameters and the at the scale it differs. But the base of both Gemma and Gemini is the transformer architecture. But in the transformer, it is a decoder only architecture, right? It takes a sequence and it outputs a set of sequence. But on top of this transformer decoder, they have added four core components, right? So I hope on the transformer decoder, you all have a good idea on that. So on the transformer, they have utilized only the decoded part. So these are decoded only models. On top of it, they have mentioned these four core components. So in the original paper, right? If yeah, so this is the original paper from Google DeepMind. They explain about the background of Llama, the comparison that we saw, all of those. So on the architecture end, these are the four components they have mentioned on top of the decoder they're using. There are not much information about this in the particular paper. They are referring to the external other research papers from which they have got this inspiration. So I have tried to include a few of the information regarding these core components. So starting with the multi-query attention. So transformer uses multi-head attention, right? We have QKV values. Like in the self-attention, we have multiple such self-attention layers contributing to the multi-head attention. Similarly, they have a concept called multi-query attention. So there is a concept like we have a queries, keys, values matrix. On training, they get updated. But in the multi-query attention, instead of having multiple keys and values, they have a single key and single value. But the query is multiple. So this is the core concept of this multi-query attention. The 2B model is using this technique, not the 7B. So since the key value is single, not multiple, it is leading to a faster inference time, right? So the inference time is so fast, but the 7B model still uses the multi-head attention. So this is the base idea behind this multi-query attention model. And they are also, they have mentioned that they are using rope embeddings. So embeddings, I hope you all have a idea on that. So embeddings is nothing but each and every word we will convert it to vectors to a machine understandable form. So how are these embeddings created? The machine itself learns to create the embeddings. For example, a particular word will get converted to numbers. So we have a huge vectors representing these numbers. So each and every word will have a specific embedding. So the embeddings will also have implicit meaning within it, right? So from that, we have position embeddings in transformers, right? So on top of that, so position embeddings are basically to also embed the position of the word in the input. But here they are in this paper I have referred. So they are mentioning a problem with the long sequences. Maybe for shorter sequences, if we mention the position, it is working in a expected way. But when we are looking at a very long sequence, the absolute position is not giving better performance. But when we include the relative positions of the words, right, it is giving a better performance. So how are they capturing this relative position? Using a rotation matrix, right? So for example, if we have a set of words, each and every word along with the position, they are passing to a rotation matrix. So through this rotation matrix, it is giving a embedding, which will have both the absolute position uh, information and also the relative position information. So by this, the longer sequences are also having better performance. So from this paper, DeepMind has inspired this concept, and they are using that in Gemma models. And also the same is being used in Gemini also.
Can you repeat this slide once?
Sorry?
These operations, can you repeat it once?
Okay, sure. So the detailed version of this is actually not given in the original paper of Gemma. So I have tried to decode this from a different paper specific to this rope embeddings. So in transformers, we have positional embeddings, right? Along with the usual embedding, we also include a position embedding to capture the position of in a sentence. So in the position, we have absolute position and relative position, right? So they are trying to capture this also. So for example, if they consider for longer sequences, they are mentioning when they capture relative position, it is much more effective. So how are they doing it? They are mentioning they are having a matrix called rotation matrix. They are implementing few mathematical operations on it, and they are applying this rotation matrix over the positional encoding. So which results in position encoding embedding, which captures both the absolute and relative information. So I have also attached this source of this paper. You can do a deeper dive to the formulas in it and the actual implementation of it. So the core of this rope embedding is to capture the relative position as well. All right. So in terms of activation function, uh, so activation function is something like we need to introduce non-linearity into the model, right? So that it can capture non-linear patterns also. Like the complex patterns, the non-linear patterns also, it will be able to capture. So this is a base about this activation function. So the activation function this Gemma is using is based on a Gaussian error linear unit. So this is the formula for the Gaussian error linear unit. By utilizing this particular Gaussian error LU, they have designed this GGLU activation function to introduce the non-linearity. So this is the activation function that Gemma is using.
When we are familiar with ReLU, like rectified
Yeah,
linear unit,
yeah.
so, and probably ALU. So,
Mm-hmm.
so this is one more kind of ALU. Okay.
Yeah.
So Gaussian error linear unit. Okay.
Yep.
So there's a mathematical formula for that,
Mhm.
for specific activation function.
Yep.
Okay, fine.
Sure. So also they have given a short note that for normalization, they are using RMS norm. One thing they are mentioning is the normalization they are applying for both the input layer and also the output layer. They're mentioning usually it is applied only in either of those, but here they have applied in both input and output layer. What normalization function they are using? They are utilizing root mean square normalizer, right? So in activation functions, they are applying this root mean square. So on applying this, they have implemented the normalizing function. So this RMS norm also have mentioned the paper from which I referred. You can refer this particular paper. So these in-depth information they have not mentioned in the original Gemma paper. They have just mentioned that they are utilizing these techniques and they have given reference to the particular paper. So these are the four core components they have added on top of a transformer decoder. On top of decoder, they have added these techniques, which Gemma uses. And they're also mentioning on the core parameters of Gemma architecture. So the context length that they are using is 8192 tokens. And the vocabulary size of this is 256K tokens. They have also mentioned about the number of layers they are using in 2B, 18 layers in 2B and 28 layers in 7B, and also on the vocabulary size for both and further more information. And the number of parameters they are using, right? The embedding parameter and the non-embedding parameter for 2B and 7B also they have mentioned. So all of these are available in the public white paper from Gemma. So moving on, yeah, we'll focus on the training part of Gemma. So their main focus is not only on the parameters, but mostly on the responsible AI this time, right? So for each and every step of the training part till the evaluation part, they have implemented strong responsible AI practices. So we'll first try to decode this pre-training part. So to give a base like what is pre-training, in pre-training, we will just feed a huge corpus of data from which the model will understand about the nuances in the language and also few many different aspects from the training data. It is not trained for any specific task or the instructions. So if we see in the Gemma 2B version, they have used 2 trillion tokens on the training data set size. And for Gemma 7B, they have used 6 trillion tokens. So what have they used? the specific data set they have not given, but they are throwing a light that it is a English only data. They have focused on English data. The source is from web documents. They have feeded code and also some math documents they have fed. Based upon all these sources, they have trained from the English data set. So this is the source for Gemma. And during the pre-training itself, they are using multiple filtering process. So for example, we saw that Perspective AI, a free API from Google, right? So like that, they have multiple methods to filter this unsafe and unwanted content. So they have a high, evaluation bar for this also. So any personal information or any sensitive data has been removed from the training data. Both automated evaluation and a manual evaluation to some extent they have done. So this is the information about the pre-training with 2 trillion tokens for 2B and 6 trillion tokens for 7B. They have pre-trained the Gemma model on various text from internet, including math and code. So once this pre-training is done, they are doing instruction fine-tuning. So instruction fine tuning is like, so now the model has learned about the nuances in the language and also other information, basic information. Now we are fine tuning it for specific tasks, including question answering, basic reasoning, or code, math, summary. So multiple, not just on a specific task, but multiple such tasks. They have curated a data set and they have trained this model so that we can directly download these and use it for our use. So within the instruction fine tuning, they have two steps. First, starting with the supervised fine tuning. So supervised is like it is a labeled data set, as you all know. So in the labeled data set, not only for the specific instruction they are doing, they also have a responsible AI kind of data set. For example, if I'm asking a wrong way of question, what is the correct way of answering? That level of training also they have done. So they will give scenarios where I'm prompting in a wrong way to this model. What is the specific information the model has to throw? That also they have done. So what is the data set they have used to this supervised fine tuning? The exact source they have not given, but they have mentioned it is a text only, English only, both synthetic and human generated data set. And the data set format is something similar to this. It is a prompt, right? So this has only English and text only, since it's not a multi-model model. So here, if we look, this is one of the example prompt, example data set they have trained. So they are also using formatting here. For example, the start of token, end of token, all those things, and they are mentioning if it is a user, and for example, in user, you will see the keyword user, and if it is the turn of the model, they are mentioning model. So all those formatting also they have used. So like a small game, they have created this data set like a prompt, and they have fine-tuned the model. So what is the exact output they are expecting after this also they have fed, and in a supervised way they have trained. And they also mention it is a LM-based side-by-side evaluation. So this is something like for example, I have trained the model and I'm keeping it as a baseline with a good performance. So after that, if I have a second version, I'm having a higher large language model again, which will compare if my baseline model is better or this new version model I have created is better. So that superior large language model, they have not mentioned what it is. Probably it would be Gemini, but they are just mentioning it is a superior large language model than Gemma. So this would actually evaluate which is better. Is my baseline better or the new version is better? So that LLM model will act as a judge, and from that they are choosing the right version. So with this, they are keep on tuning the hyperparameters, And with the side-by-side evaluation with the LLM as a judge, they are choosing the right model. So this is on the supervised fine-tuning. And one such example prompt is this one. So after this step, they have used RLHF, which is reinforcement learning with human feedback, which is a super hit method with OpenAI as well. So the same they have used here, but they have mentioned they have used a variant of reinforce. So reinforce is a method in RL, reinforcement learning. So that variant they have used for RLHF along with the human feedback, right? So for this also, they are using LLM as a judge. After they have designed a reward model, so step one would be they will have to train a reward model. The data for that would be both a synthetic data and a human generated data. Synthetic data is like the model itself will create some synthetic data, augmented data. And also with along with the human prompt, they have trained this reward model. And after that, based upon the human feedback, they have continuously retrained with RLHF. So after these two steps, they have released the instruction tuned variants, which we saw the Gemma Instruct 2B and Gemma Instruct 7B. So these are the overall information available in the white paper. All right. Yeah. So coming to the hardware part of it, right? So they are using TPU V5E. So there is a detailed blog from Google itself about this TPU V5E. You can refer to this blog. But generally, they are mentioning about the chip and they are using pods to train these models. And the optimizer information also they have mentioned. So which one they are using, and for 2B, what is the hardware used? For 7B, what is the hardware used? So all those hardware information is also available. For a deeper dive into this specifics on this TPU V5E, you can refer to this detailed blog covering that.
Is there any information they gave on the context size for 2B and 7B?
The context size, yeah, it is 8192 tokens.
Same for both.
Yeah,
Okay.
and the
And
vocabulary size is also same for both.
and Gemini latest has the two variants. What I saw, one is the Gemini Pro and Gemini Pro Vision. So, is there any idea that you want to say on this? Like both of these, which one is the instruction Pro and Vision, or maybe it is a separate for Pro and Vision?
Which two models are you mentioning?
For Gemma, there are two
Huh.
parts, two variants probably,
Yeah.
Gemini Pro and Gemini Pro Vision. So which one is the instruction one, or is it different? Like, if it is instruction, then they will specifically say instruction. If it is not, then maybe the junior one. Any idea?
Okay. Maybe not sure. Your voice is little breaking for me. So you mean within Gemini you're asking, or you're comparing to Gemini? I mean, sorry, within Gemma you're asking, or you're
Yeah,
comparing with Gemini?
within Gemma.
Within Gem. Okay. Yeah, as we saw here, there are four models, four checkpoints that Gemma has. So the first Gemma 2B English and Gemma 7B English falls under pre-trained. And the Gemma Instruct 7B and 2B falls under fine-tuned.
So all of these four are text only, right?
Yeah, text only English-based models.
Yeah, there is also a vision part, Gemini, uh, Gemma vision part, I guess.
Sorry?
Vision, the Gemma
Vision. Okay,
also.
okay,
So that is
okay.
what.
Yeah, Gemini handles vision, but this Gemma, it handles only text, English text for now. Like we saw here, Gemini versus Gemma. Gemini handles multi-modal features like images, videos, all those. But Gemma is only for text.
Okay, got
Yeah. All right. Okay, we will see on the coding part now. To run 7B, right, we need a 20 GB RAM. But for 2B, we need only 8 GB RAM. 20 GB RAM is not available in usual collab. So if you want to run in, the 7B version, you would need a collab enterprise version. In the collab enterprise, we can run 7B for fine tuning all of those because the RAM size, the RAM requirement is different for 7B. It needs 20 GB. So the 2B version, it just needs 8 GB RAM, which we can run in Kaggle, Collab, all those, right? Yeah. So the general practice is to, get a consent from this Gemma site. Once that is done, we can access the models. The other way is also possible, but the recommended way from Google is we'll have to go to the site, agree to their terms, and then start using it responsibly. So we'll see a quick demo on the base variant. Yeah. So here, what I have done to mention, Gemma is available in multiple environment, and the easy way I'm using is the Keras NLP. It is also available in Hugging Face, right? Uh, so they have a model card on the Gemma, and just in the usual way, we can download Gemma models and use it. It's very simple. We can even run in a CPU with 2B, but the RAM size requirement, we should keep a note of it. So I'm using Keras NLP version with Gemma. From Keras NLP, I'm going to install and use it. So initially, I'm doing the basic setup. I'm going to access the API. So I have given my Kaggle username and Kaggle key. So here, for privacy reasons, I have not mentioned. If you want to do the same way, you can give your secret key here. In Collab, there is a feature called secrets. Here you can set up your Kaggle username and Kaggle key from which it will take it. So I'm just doing the basic setup for the credentials and I'm installing Keras NLP. Yeah. So after importing the basic packages, now I'm going to create this model for Gemma. So since this is a basic collab, I have connected for GPU and my RAM is less only. So this is a basic collab version. So from the Keras NLP, from the models available, I'm using the Gemma Cos LLM from which I'm downloading this Gemma 2B EN. So this is the basic pre-trained version. This is not a instruction tuned version. This basic version I'm just importing. So from this, we can also see a summary of this 2B. The same things that we saw, the number of parameters, the token embeddings, all those basic summaries like the vocabulary, tokenizer, all those we can see. This is just for the information. So the main thing is we want to generate text out of it, right? So we have the Gemma model loaded here and using this generate function, I'm just passing a prompt. right? So my prompt is what is the meaning of life? And the maximum length I'm setting as 64. So this is the output that it has generated. And even with the pre-trained version, it's much more meaningful, right? For what is the meaning of life, it's predicting and generating in a right way. So likewise, you can play around with the parameters and the hyperparameters they have. You can change the sampling. For example, instead of greedy sampling technique, I have used the top K sampling. So likewise, all the parameters, the maximum length, you can change and play around. So the responses would have a slight variation depending upon the tuning. The responses would differ. So they have that flexibility also. So if you do not want to, go through the coding way, you just want to explore the models. There is a inference tool available in Kaggle. So in Kaggle, if you just search for Gemma, you will get this page. So where you can choose which model you want to try. Let's try the Instex 7B model, the outperforming model, and then you can just give your prompt.
So,
So this,
so
yeah,
how kind of an identity, this kind of things are reusable identifiers. So we need to address the problems because of this kind of an reusable identifiers as part of the historical research usage system and configurations. So views can be views are available today, but it can get deleted in the next moment, and borders can change. It's not just get changed only the current time, what happened yesterday, what was the quota last week, and things like this. So let's look at the slides very fast. We have two more slides. So what we have done here is present an event system, which will take care of pushing the events as and when the things are happening. And
I
then
think Kiran, your voice is breaking up.
yeah, yeah. I
Um,
can't understand
I can't
also.
understand what you are asking, Kiran. Maybe you can write your question in chat.
Yeah.
I don't think he was asking. I think he was discussing with someone else. By mistake, he unmuted.
Oh, I see. Okay, okay, fine.
All right. So as I mentioned, the coding is also very simple. We just have to import the libraries and generate. If for no code, if you just want to explore around, right, you can choose the model and you can, give a prompt. They also have some recommendations like give me a workout for beginners. It will generate this. So as we saw, it has outperformed most of the other LLMs. So the results are also really nice. So this is one easy way to try it. As developers, we can use the Hugging Face um, code and also the Keras NLP code. And in Kaggle also, the Google has released a lot of example codes. So there are a lot of sample notebooks already available from Google. We can leverage those notebooks as well. So this is a
Chandra, will you be able to share the notebook which you just showed? Will it be possible to share that?
yeah, sure. We'll share.
Thanks.
Sure. Yeah. So this is a very basic implementation. Just we imported and generated a sample thing. So we will see if we can fine tune these models, right? Yeah. So this is a notebook from Google itself. They have multiple such notebooks. There are a lot of examples. If you go to GitHub and GCP platform with Vertex AI, within Vertex AI, they have a lot of examples worth trying it out. So we'll focus on this fine tuning part. Yeah. So as I mentioned, this is using Vertex AI, but you can use any platform you're comfortable with the setup for that specific platform. So we'll just look upon the no required things, not focusing on Vertex AI here. So fine tuning, to give a note on it, for if we want the model to be performing better for our specific custom data or our specific custom use case, we will do a model fine tuning for our use case and for our data. So taking these base models, we will see how we can fine tune these models for the data and the use case that we have. So the same Keras NLP we'll have to download, and the sentence piece, tokenizer, transformers, Hugging Face libraries. The basic setup we'll have to do, right? The installing these libraries, importing we'll do. And then we will be using the model APIs from Kaggle. Like how we did here, we'll have to set up the secret key for Kaggle username keys. We'll have to do the same thing here. So the Kaggle setup we'll have to do, and whichever platform you're using. Here it is Vertex AI from GCP. So the GCP setup, all those we'll just have to do. After that, we'll have to import the libraries required, including Keras NLP and the tokenizer and Hugging Face library transformers. And then here we are taking a pre-trained model, not the instruction tune model, right? Because pre-trained model, it is so basic. It has just learned the basic information about the training data, about the language. So we are taking this to make it more customizable to our data set, right? So what is the data set we are taking? It is a Databricks library. I mean, sorry, Databricks training data set. So this is a data set where this employees from Databricks, right? They have curated this human-made prompts. So all these are developed by humans, not a synthetic data. So it contains like the basic, what is the context and what is the instruction given, like the question, and what should be the response. If you notice, it's not specific to a particular task. It has classification, open question answering, closed question answering, information retrieval like extraction, and complex tasks like brainstorming. All such multiple different tasks, the human generated data set is available. They also have training set, test set. So this particular open source data set we are taking. Right? So by taking this data set, we are going to fine tune this pre-trained model. Yeah.
Oh, interesting, because Databricks has the data set for their own LLM, which is called Dolly 2.
Uh-huh.
So Databricks has made that data set public.
Yeah, it's open source. Yep. It's a nice one. Yeah. So taking this data set, we are loading it. And there are a few techniques for fine tuning. There is a half precision technique, like instead of having a heavy load, we will utilize this half precision version float 610. This is a common technique for fine tuning. And also, like we saw the summary of this model, you can also find the summary for this, the total number of trainable parameters. If you take a closer look, it's so huge, right? It's around 4 GB, and how much it's such a huge parameter that needs to be trained. So it is really difficult to train such huge parameters, but there are many efficient ways for it. So one such efficient way is the parameter efficient tuning, right? One of the technique is LoRa. So LoRa is a famous technique to fine tune these models for low rank adaptation. So which we'll be using here, right? So in LoRa, if you compare, So LoRa, you can do a deeper dig. It's nothing like, instead of taking the whole parameters that a model has, only by choosing a few parameter also we can achieve the same performance. So if you see here, the total parameters to be trained earlier was around 4 GB, but now it has reduced so much, right? Only in MBs. So the reduction is around 1800 times. This is not specific to Gemma, it's a general technique available for all LLMs. So that same LoRa technique, we are also leveraging that for Gemma models. So before this, the same, so let's see what was the result without fine tuning, right? So without me doing anything, if we just take the same pre-trained model, which is Gemma to 7B English, if I ask these questions, let's see what are all the responses.
Chandrika, any idea about this quantization or like the one bit LLM which is becoming now famous? The quantization is also a way of reducing the model training size, right?
Yeah,
Model
yeah.
and second thing is one bit LLM recently became whatever
Hmm.
the Microsoft had launched. Any points on that?
What was second one?
One bit LLM.
Okay, that one I'm not sure.
Yeah, I think that paper, Vishal, came like 3-4 days back.
Yeah,
So
yeah, it's
yeah,
very
one
latest.
LLM is brand new stuff. It came, I think, last week. So
Correct.
we have, in fact, we have a webinar on that as well lined up later this month.
Yeah.
Okay,
Thanks,
great.
Vivek.
Yeah, the quantization methods will also definitely help. The B float 16 we have used, right? That should also be helpful. The precision, the quantization, whichever, on top of LoRa, there are a lot many newer techniques. We can implement those as well. So if we take without any fine tuning, let's compare the results. For example, let's see this question from the testing we are doing. So if I ask what are good activities for a toddler, if you compare the result, right, it is just a simple generation. It is just keep on repeating what are the best activities for a toddler 4 times. This is the expected behavior of the model. Its core thing is to keep on generating based upon its learning, right? So this is how the pre-trained model will be. But we want this model to be fine-tuned for this data set. If I ask a question, looking at the context, it has to give me the expected response, right? This particular behavior we are expecting. So let's see how from this response we can convert to the expected intelligent responses. So that's where this LoRa quantization, all those techniques comes in. We are using the basic version LoRa technique. We have libraries for that. Just we'll have to enable the LoRa. And as I mentioned, after we enable this low rank adaptation, the number of trainable parameters has reduced 1800 times. So the fine tuning becomes much easier now. And the usual process, we'll have to mention the models and the parameters, the learning rate, all those we'll mention. You can even enhance this. You can even use advanced techniques here. So the basic parameters we have initialized and we are fine tuning it. So after the fine tuning, let's compare the results. So the same question, what are good activities for a toddler? Earlier, it was just the question was getting repeated. After this fine tuning, the responses, the best activities are those that are fun and engaging, right? So this is what is all about fine tuning the pre-trained version. So the pre-trained version would be a very base text generation model. Whatever specific task that we are looking to, whatever specific data set that we have, we can fine tune those easily using these techniques. So if we compare for other questions also, the responses are more like a question answering. So this is on fine-tuning Gemma. And we have one important emphasis from Google, which is the LIT models. So both this base version and the fine-tuning version, I have included the links. I will share with Vivek. You can refer those later. So similar to this, they have many complex fine-tuning and complex use cases. Notebooks also available here. You can find those. So let's do a dive into this LIT, which is an interesting one also. So since Gemma is focusing more on responsible AI and it's expecting the developers and researchers to always practice responsible AI policies, they have leveraged this LIT tool, which is learning interpretability tool. This is not from like Google or Gemma. It's an open source tool available. So like for tabular models, we have this explainable AI features, right? We have model interpretability. The same way we have for NLP models also. Like we can see why the NLP model is giving such an output, which part of the input is influencing my output. So all those interpretations we can do. So in LIT, they have lot of different methods implemented, lot of APIs available. This is really an interesting tool for NLP models. The specific thing which they are suggesting for Gemma is this salience map, right? So using the salience map, they have implemented this model interpretability for Gemma. We will do a deeper dive into that. So this LIT model, you can this particular tool you can use for other NLP models also. It's really interesting, and we have a lot of tutorials on that. So they also have a code lab if you want to try it out for your own model. I mean, your own fine-tune model. You can load those and try it out. So they have step-by-step implementation, like how to do it. So I'll throw a light on the salience method. So salience is like the explainable AI technique. So here we are focusing on sequence salience. Sequence salience is for the sequence to sequence methods, right? The sequence to sequence is like from a set of tokens. The output will also be a set of tokens, which is a sequence. So if my output is 3 words, if I'm choosing the word number 2, I can track from which part of the input I'm getting this output. It will assign a scoring method for each and every words in my input, showing the magnitude and the influence it has on the output word, right? Like very similar to the attention mechanism, we are using the same for the interpretation. It will give a score, it will give a magnitude of the influence of the input word to the output sequence. So to implement this, they have complex methods like SHAP and LIM, but they have a very cost-effective and a simple, efficient method using gradient techniques called grad L2 norm. So basically, it will be using the gradient methods to analyze the magnitude. So the magnitude scoring it will do, and it is a simple and efficient one. So we also have these complex explainable AI techniques, but this is good enough is what they have mentioned. So we will also be using the sequence salience and the grad L2 norm method here, right? So all these required things like the Keras NLP and the LIT tool, right? LIT NLP and Keras NLP we can install. And we are taking the instruct 2B version here. So our goal is to predict, like we want the tool to explain how it has come up with that output. What is actually influencing the output factors? That is the goal. So for that, the basic setup we are doing with the Keras and the LIT, we have chosen this Gemma Instruct to be English model. And then we are loading it with the LIT models and the Keras model. We are linking both. With the LIT model, we are linking this Gemma. And then for the data sets, they have multiple suggested data sets. But for this particular, we are taking LM data set. LM data set is like, we will see what it is. I will show you. It is like a set of prompt. Some will be a right prompt, some will be, wantedly created wrong prompts, which we can use for our exploration. So this particular data set, let's try to explore the data set first. Yeah, so this is the data set. So these are a lot of prompts. For example, this is about the restaurant menu. For example, I'm giving what is my taste like. I have a sweet tooth, but I do not like onions or garlic. So the suggested recipe in the menu is onion soup. The analysis it has to do is it has cooked onions in it, which you don't like. And the recommendation should be try to avoid it, right? But wantedly, they have given a wrong answer. You have to try it. Yeah. So likewise, we have good prompts and wrong prompts also. We will maybe with these number of small prompt, it is easy to identify that. But with a higher scale, we can't even we manually identify such wrong prompts, right? So is there a way to try like interpret this, and is there a way for explainable AI for NLP models? Is what we will explore now. So after the basic setup, after all those, right, we will try to see what's happening behind. So this is the few short prompt we have given. So for now, we have taken these prompts, and this is the new input that I'm giving. So my like is cheese, but I dislike egg. And this is a French recipe which has both cheese and egg. So what would be the output is what we are going to see. But we have a wrong prompt in it, right? So this is a wrong result. Let's see how the model behaves now. This is the LIT tool. As I mentioned, the sequence salience will give a magnitude score for the input sequences, right? So these are the uh, few short prompt inputs that I gave. And the one you see below is the new input that I'm giving. So the new input I gave was cheese and the dislike was egg. And in the suggestion, it's a new recipe which has both cheese and egg. What was the output is you might not like it, but it's worth trying. Even though I don't like eggs, it is telling me it is really worth of trying it. So this is not the output that I'm expecting for, right? So let's try to debug why it is telling me such a thing. So we are using color gradient here. Higher the color magnitude is the more influence it has on the input. So if you look at it, the highest magnitude lies here. Analyze the menu. So the prompt it is following. And also it is following that it has cooked onions in it, which you don't like. This also it is taking as a highest consideration. And if we see the next magnitudes are into the cheese and eggs, onion, garlic. So based on this, from its past experience, it has learned, even though they don't like it, you have to try it, right? So the same behavior it has replicated here. Even though they can't eat eggs, it is suggesting, but it's worth trying, right? So where is this useful? Maybe we might be having a abusive prompt, abusive comment. For example, in a movie, a comment, right? Sentiment analysis. We might be having a very abusive comment. If the model is giving a hate speech, this will be helpful for us to backtrack. So it will give from which input that we gave, from which part of it has actually predicting it. So what will be my natural next step? I'll have to edit my prompt. I'll have to change my input accordingly. Let's try that. Let's see if I change, what will be the magnitude, what will be the effect. Let's see that. So in the next, I have changed my input. So in the input prompt, in the example, I have changed my recommendation as avoid. Since they don't like onion and the suggestion is onion soup, my recommendation is just avoid it. So let's see what is the output now. So for my new input with cheese and eggs, and I cannot eat eggs, the output is not suitable for you. Let's see what was the input that made this change, right? Which was actually influencing this? If you see, the maximum magnitude lies in these two areas. Analyze the menu. And with this, we have mentioned you should also consider the suitability for someone with a dietary restriction. So with this specific prompt, it has the highest influence on this output. So likewise, we can keep on experiment. We need to implement these for more responsible AI practices. If the output is biased towards a community, it is not fair towards a community, or any other unfair practices, right? We can always trace back from where it is actually doing it to the NLP models, and we can change our input accordingly. We can change the prompt also accordingly. So this is one of the technique that Google is suggesting, to use LIT tool to analyze Gemma models. So this is so this link also I have included here. So I hope this was clear, like how we do explainable AI for other models, we have for NLP models also. So Google has emphasized this to adopt responsible AI practices. So yeah, I'm done with the presentation. Let me know if you have any questions.
Okay, nice job, Chandika. So, audience, any other questions? There is one question here on the chat. Responsible AI principles are imbibed during training itself, or guardrails help us realize this post inference?
Okay. Yeah, so from Google end, starting from the data collection, training, evaluation, in all the steps they have highly emphasized responsible AI practices. They are filtering out a lot of abusive or any unsafe content. After they have released as an open model, right? From our end also, they are emphasizing to implement guardrails as a developer's responsibility. So how do we implement those? They have given a very detailed guide for that. Like few examples is to include Perspective AI API, which is a safety classifier. It will classify out any unwanted content. Paid and free version they have. So similar to this, they have a lot of suggestions in this toolkit. We can refer to that and implement the guardrails accordingly.
Okay, good. Any other questions, folks? Okay, so thanks a lot, Chandika. Excellent presentation. Thank you, audience,
Yeah.
for on this Saturday. Uh, Indeed, fantastic session. Good comments are coming. I echo that.
Sure. Thanks. Thanks a lot, Vivek. Thank you, everyone. Thank you so much.
Thanks, Chandika.